On the first three questions here, we have the dreaded fractions. So let me ask you a question. Whenever you're solving a problem and you see a fraction in it, how does it make you feel? Does it give you a little bit of anxiety? Does it make you reach for the calculator? Because for some cruel reason, I'm asking you to do these three problems without a calculator. And there's a couple reasons for that. First of all, I want you to have this level of comfort with any kind of number that a problem throws your way. And then also understand this, that STAR test that you took for Algebra 1, it's the last end of course in math test that you're going to have to take. There's not one for geometry, there's not one for Algebra 2, nothing like that. The only test as far as math is concerned for you guys from here on out is going to be something like the PSAT, the SAT, which are college entrance exams, and then any AP exams that you choose to take. The PSAT, the SAT, and one of the AP exams, that's a calculus one, parts of them are supposed to be taken without a calculator. And I want you to be comfortable with working with whatever kind of numbers a problem throws your way without getting this kind of anxious feeling about, oh my God, there are fractions in here. All right, so let's take a look at these first three questions. And you can see that they're exactly the same fraction across the board here, but one's asking you to add, one multiply, and one divide. Let me ask you, if you were going to rank these from easy, medium to hard, you're going to put these in a tier list of some sort. What would you say is the hardest? What would you say is the easiest? In terms of like operations, when you first learned to add, subtract, multiply, and divide, adding was the easiest thing. And you might think that adding fractions would be the easiest of the three too, but you would be wrong, at least in my opinion. This one is actually the hardest one. This one's hard. And the easiest one is actually the multiplication one. This one's the easy one. So why is that? What's the difference between these two things? There's something you got to do over here on number one that you don't necessarily have to do on number two. When I say you don't necessarily, you absolutely don't have to do it. If you're multiplying two fractions together, do you have to get a common denominator? Remember, these are called numerators. These are denominators, the top versus the bottom. Do you have to get a common denominator? No, you do not. Do you cross multiply when you multiply? No, you don't. That is a super common mistake. And it's probably because recently you have to solve these things called proportions where you have equal ratios or equal fractions. And when that's the case, you do cross multiply. But here, not so much. Okay. And then the division comes in a strong medium here. Medium as far as difficulty goes. So what makes number one the hardest of the three is the fact that you do have to get a common denominator, something that doesn't happen on multiplication and division. So let's break down the multiplication of fractions in just a little bit more detail. So looking at this picture here, when we are finding the product, multiplying product, we're finding the product of two fractions. It's so simple. All you are supposed to do is multiply the tops together and multiply the bottoms. Top times top and bottom times bottom. And that's what this picture over here is illustrating with these two lovely people here where same shirts, same bottoms, they're multiplying their tops, they're multiplying their bottoms. That's all you got to do. In terms of like algebraic example here with some letters, I have the fraction a over b multiplied times c over d. And I'm just going to multiply a times c and b times d. And then you reduce your answer if that is possible. So here, let's take a look at a quick example. I don't want to give you the answers to the actual problems that you are supposed to work on. So let's take a look at a sample problem. Let's say that you have the fraction 1/2. You're multiplying this times 3/5. Very simple problem. Multiplying fractions, we just multiply straight across. So 1 times 3 gives me 3 up top. And 2 times 5 gives me 10, right? Easy, 3/5. I mean 3/10. I'm going to put a box around that. Now, question is, like, why is it that you do that? Like, you've been trained to do that, but why? And that's one of the things that we tend to ask in our honors math classes, especially in honors geometries. We want to know why things work the way that they do and give some sort of valid reasons for this. So Believe it or not, back in sixth grade math, you probably saw some diagrams that are sort of like this. So here is a visual representation, first of all, of the fraction 3/5, right? We can see that we've taken this bar right here, and we've broken up into three, not three, but five equal parts. And the fraction 3/5 is, of course, just coloring in three of those five things. All right, now let's say that I wanted to take half of that 3/5. Well, if I want to take half of that, I'm just going to basically break this thing in half and break this one in half and break this one in half. But then to make them all kind of match up so that I can get one complete fraction, I need to break these things in half as well, even though, I don't have any kind of shaded portion on them. Now, whenever I count this thing up, I can see that I have a total of 1, 2, 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 3 out of 10. Go away. Delete. Boop. And so instead of having to do that every single time, which is what the diagram is trying to demonstrate, you can see that that 3 of those 3 parts that I got to keep is the same thing as the 1 times the 3 that's right up top. And then the 10 of the 10 pieces that are all of the triangles, basically the right triangles that are in the picture, that's the same thing as multiplying the 2 times the 5. All right, so going back up here to our original question here, on question number 2, which is the easy one of the two, again, I'm supposed to multiply just basically straight across. Now, one last thing though, and I'm going to give you kind of a pro tip here. When you're multiplying without having to use a calculator or not getting to use a calculator, you want to try to reduce your numbers as much as possible before you start multiplying. The reason why is because obviously multiplying with small numbers is so much easier to do than multiplying with larger numbers. So let me give you another sample problem right here. Let's say that I had 7 12s, and I'm going to multiply that by 21 over 25. Now, these aren't obnoxiously large. You can do some multiplication to get these and then reduce whenever you're done, but it's going to be a lot easier to do if you reduce before you actually multiply, and it makes your numbers a little bit smaller. So looking across here, let's say I look at the 12 here. I know that I could factor that. The 7, it's a prime number. The 21, I could factor that, and the 25, I can factor it. I'm going to rule out factoring the 25 because it's 5 times 5, and no other number up here has a factor of 5 in it, so I'm just going to kind of leave it alone. However, the 21 is 3 times 7, and then the 12 over here is the same thing as 3 times 4. And what I'm going to do is I'm going to just cancel out these common factors of 3. And why do they cancel out? What is, let me ask you, 3 over 3, which is essentially what we're doing here. We're basically kind of rearranging the factors, even though you don't usually write it like this. It's a combination of the associative property and the commutative property. Associative means that you can move things around, grouping things when you're doing multiplication, and whenever you are changing the order, that's the commutative property. 2 times 3 is the same thing as 3 times 2. So let me just kind of rearrange this. Bring the 3 up front on the top, 3 over 3, same thing on the bottom. And then I'll have my 7, and then I'll have my, that's the other 7. So we'd have a 7 here, and we'd have another 7 right here. So 7, joop, joop. And then I will put a 4 on the bottom of this one, and then a 25 on this one. So basically what I just did is I just kind of rearranged some of my factors here. I still have all the numbers accounted for. Here's a 7, here's a 7, here's a 3, 7, 7, and a 3. Down here on the bottom, I have a 3, a 4, and a 25, 3, 4, and a 25. And then just look at this, 3 divided by 3. That is what we will call a fancy 1. It's the number 1 because 3 divided by 3 is equal to 1, but it's a little fancier than 1 usually looks. So if you multiply something by 1, it doesn't do a whole bunch, so we just kind of get rid of it. You don't have to like rearrange your factors like this. I just wanted to justify it as to why we would get to just cancel out those factors in that way. Now, The stuff that you're left over with when we do this multiplication here is so much easier to multiply. I got 7 times 7 across the top. I got 49. And on the bottom, I have 4 times 25. I have 4 quarters. That gives me $1. That is 100. And then I'm finished with that. So once again, whenever I'm multiplying fractions, I'm going to multiply straight across, top times top, bottom times bottom, and reduce if you can. However, if you reduce before you even multiply, it makes your numbers smaller and easier to work with.